From UFOs to psychic powers and government conspiracies, history is riddled with unexplained events. You can turn back now or learn the stuff they don't want you to know. A production of iHeartRadio.
Hello, welcome back to the show. My name is Matt.
My name is Noel.
They call me Ben. We're joined as always with our super producer, Paul, Mission Control Decant. Most importantly, you are here. That makes this the stuff they don't want you to know. Breathe in the air.
Do you have a mantra? Do you guys have a mantra when you meditate?
I have
when
a
you're
few.
doing breath work?
I have a few, yeah. But we were talking about this just briefly off air. Tonight's episode, we're diving into some stuff that maybe we didn't all appreciate in grade school, because it's like, why do I have to learn all these abstract facts?
Oh, dude, that's where it's been coming back to me from. Like, I'm flashing back to like middle school and maybe later elementary school, learning about photosynthesis and like the water cycle. I'm literally picturing these diagrams from textbooks. They're flashing through my mind.
Yeah, my mantra is phosphoglyceride.
That's a good one. That is a really good mantra.
Glyceride.
Wow. Right number of syllables.
Mine is
too.
goose fraba.
And so a while back, folks, we on, I think, a strange news segment, we talked a little bit about a fascinating study that led us collectively to a new appreciation of one of Earth's most underrated life forms, plants, towering trees, humble shrubs, weeds, everything in between. And weed, by the way, is a very unfair linguistic trick.
Oh, yeah. Except for like, the one that you smoke. That one, for some reason,
which is
okay.
slang.
Yeah,
totally
for sure. But what makes a shrub humble, though? I love that because it feels that way. But what makes a shrub so humble? If you combine a bunch of shrubs, it could be quite ostentatious.
Mm-hmm, especially if you trim it into a topiary
shape.
shape. The thing is, again, for all of human civilization, people have been anthropomorphizing everything in the world around them. And of course, plants are no different. We owe all of civilization, this is not hyperbole, all of civilization to plants. And for most of history, that was awesome. That was not a problem. Plants were dope, 10-10, no notes for now. So what may change, and when would it change, and what does that mean? Here are the facts.
Give it up to plants.
Woo.
You like steak? You like plants.
Wait a minute, what?
Yeah.
were those like coexisting, or is it like if you like steak, you'll like plants?
Can't have steak. Can't have steak without photosynthesis, baby.
That's also true.
You can't have your favorite things and your least favorite things. You can't have them without plants, and because of their superpower photosynthesis. The world,
you can eat it too.
Yeah,
like
plants.
literal superpower.
It is a superpower.
Like
wild.
I understand the science, and it still doesn't really make sense, like how evolution just brute force hacked that one.
Well, we're going to get into it, but like literally, so sunlight is the powerhouse, right? The sun is the powerhouse for all life that we know. And somehow these cells specialized in a way to take that sunlight and all the water that's going on this planet and make stuff.
Well, and not to mention the whole Goldilocks zone of it all, that the sun is also the perfect distance away to give us that, rejuvenating energy without like frying our eyeballs out of our skulls or setting the forests on fire.
For now. Yeah,
I'm just saying the perfection of this fluke, whatever you may believe, the science of it is bonkers, and the fact that it works and just kind of always has been, it's mind-blowing. And then we figured out how to farm, and just kind of extend that whole natural process.
Yeah, I agree. It's pretty fascinating. I'm always taken with the order of operations cognitively of the Goldilocks zone argument, because if life evolved very differently, if it were on, say, another planet in the solar system, would that planet's life forms not also make the same Goldilocks argument? We evolved to fit the shoe. The shoe did not evolve around us, right?
No, you're totally right. The plants developed those abilities because of conditions over time, right? Like I say, it was always there, but in our minds, it was just like, this is for you, for shade,
right.
For sustenance, for medicine. I mean, it's it's a whole other ball of wax.
Yeah, there's a reference I had to cut to Sean Connery's Medicine Man. It didn't have anything to do with it. It was just a reason to talk about that film.
Well, you brought it back. Tell us about Medicine Man.
That counts. No, you could go on
he
that
was a
adventure,
grumpy.
folks.
He had a ponytail. I remember he had like a white ponytail, and he was sort of a Jane Goodall type figure, like a bit of a white savior story, if I'm not mistaken.
A bit,
I think
sure.
it had a little problematic. Well, it probably didn't age well, but I do remember seeing it in the theaters.
Same. And then as now, in the theatrical run of Medicine Man, as well as the ancient past and the current day, as you said, Matt, the world has always, for the most part, run on solar power. Something that I think we all look back on fondly was during the days when the giant nonfiction company Discovery owned our little podcast. They would occasionally send us these very high production value, prestigious documentary collections, Planet Earth and, of course, Life. And one thing that got to me about those that still stays with me is that observation that almost every single earthly ecosystem, regardless of how different they may appear to be, they all depend on the sun for energy, with like a few exceptions. I think one would be deep sea thermal vents. Those little mini ecosystems, they get their energy from those hydrothermic off-bleeds.
Yeah, anything in the abyssal system where the light no longer reaches, you can count on other energy sources being utilized.
You could also say that they still get solar power just through more steps because of animals that are closer to the surface of the ocean when they die or are predated upon.
One thing about all the crazy adaptations that results in, that these particularly deep sea dwelling creatures that have like headlamps and stuff, and again, part of the whole system and the whole Goldilocks zone of it all. Like that particular zone created that particular type of life, but the sun still kind of, like you said, was involved.
I mean, think about it. Like, okay, this is one of the dumb facts that still captures me about those documentaries. Cave systems, even the majority of cave systems get their power through the sun, but in what humans might call a somewhat ignoble way. They get it from excrement, from like guano. When bats fly to the surface, they fly back in. And I can't remember, was it David Attenborough who narrated those?
Oh, he did the Planet Earth ones, but then there was like a recut version where I think Sigourney Weaver did it. Right. There was also, obviously, I'm sure that Morgan Freeman has done some over the years. But yeah, Davey Attenborough is the main guy. Talking about guano, I always think about Ace Ventura, When Nature Calls. That's what I think of when I think of guano.
I just remember our pal, I think it was Dave, and Dave, apologies if I get this wrong, but I remember when our pal was like, "What about caves? Surely they don't use the sun." And I'm sitting there, I'm like eating a sandwich.
They totally
and he's
use
like,
the sun.
"Not so fast. Observe the humble bat."
That's very good, Ben.
That's like, he's into it. And so we're all, even though we may not all universally love the sun, we can admit that it keeps Earth going. In addition to feeding everything and plants, it creates wind, oceanic currents, clouds to transport water and inspire poets and so on. For about 5 billion years, this guy has been amazing, the sun, and a potentially catastrophic power source. And people don't spend too much time, thinking about the grand scheme of things in a scientific bent. For much of human history, we just sort of always knew, everybody always knew that the sun is the creator of livestock, agriculture, you know what I mean? And National Geographic had a great quote about this, about how the sun's placement even affected architecture forever, basically.
Well, yeah. Is that, we're talking about where we put windows and entrances?
Mm-hmm.
Yeah, it's a big deal.
Yes, and the quote goes, early civilizations around the world positioned buildings to face south to gather heat and light. They used windows and skylights for the same reason, as well as to allow for air circulation. Genius. And like we haven't really improved on that technology, at least in terms of like dwellings, you know? I mean, obviously there's climate control and stuff, but skylights, windows, if you don't have those, all your plants are going to die. All of your house plants are going to die. And I mean, you can get like grow lights and stuff, but it's so key to have that sunlight entering your house directly if you're going to keep plants alive.
Well, yeah, it also changed like what types of materials were used to build those houses and structures, right? Because some materials absorb that heat from the sun a little better than others.
Yeah, stone and concrete, for instance, and also the construction of greenhouses leveraging solar power to grow plants out of season or in otherwise inhospitable climates, aka that with the global shipping conspiracy is the reason that you can eat so many things in far-flung areas of the world. At every step along the way, plants have been right there. You know what I mean? They've been the is Andy Richter the guy who works with Conan O'Brien?
He did. He got his own show eventually, but yeah.
Plants are the Andy Richter
right.
to the sun's Conan O'Brien. And
yeah, because they make oxygen too.
They do. The sun does not care really about
if the sun
people.
is God, then plants are like Jesus. You know what I mean?
That's good too. Yeah. And I mean, this is all, we could all listen to this and say, yeah, this is basic stuff, solar architecture. I get it. I don't have to be a biologist, a botanist, or an astronomer to get my mind around the basics here. You guys are talking about photosynthesis, fundamental part of life. It's up there with how everybody knows. I still don't know how this became a meme, but all of us know one thing about mitochondria. It's the powerhouse of the cell.
I didn't even know that one thing.
You knew that one thing. That's like
it was probably tucked away somewhere back there, but yeah.
Well, we all learned about photosynthesis if you went through basic schooling and took any kind of life science class, right? I mean, it's one of the first things you learn. Photosynthesis. Whoa.
I just remember the drawing of a leaf with little animated rays of light going in with arrows on it on one side and then coming out as little blips of like molecule models or whatever. You remember? You guys picture it?
Yeah, I loved it. Yeah.
Well, and they'll break it down for you. In preparation for this episode, a lot of us looked back at just relearning, right? All the things that we learned as kids. And one of the greatest things you can do right now is head on over to YouTube and just watch some of the Khan Academy videos from like 2010 that actually break that stuff down the way you're describing, Noel, with diagrams, with a professor sitting there and showing you, here's all the stuff. It's not like, what was that movie, Chlorophyll, more like Borophyll? What is that? Why was that in my head?
I don't know, but I do remember it. I remember that phrase.
Oh, God, that is a movie. Somebody write in. What movie is that? Anyway, it's so amazing to really look at it and see the biological structures that exist within plants that actually do these processes, because it is just a beautiful machine at work in every leaf that uses photosynthesis. Billy
Madison.
That's it.
Billy Madison. Oh boy, I wasn't expecting Adam to show up. But welcome, Mr. Sandler. You're absolutely right, man. That's such a beautiful description. It's going to set us up for a beautiful episode in a later evening about whether plants are cultivating humans and what the nature of that relationship is. So this is all true. Nothing is controversial about this. This is all biochemistry and botany that we have learned some piece of in most of the world. But there's a new wrinkle occurring, but a wrinkle that has some scientists, not all, but some, incredibly concerned. Riddle is this, folks. What if at some point in the near future, plants just sort of stop working? We're not talking about a world of, sentient plants going on strike or taking collective action. We're talking instead about a world where photosynthesis is no longer possible. And why? That should terrify everyone. So let's take a break for a word from our sponsors, and we'll be back so long as we have enough oxygen to continue. Here's where it gets crazy. Bonkers, right? Plants without photosynthesis? That's like a McDonald's that doesn't make fries.
Yeah. It wouldn't be great. And just so everybody understands, we're talking about photosynthesis. Okay, there are two things here, right?
Mm-hmm.
Photosynthesis as a process. Is it possible there's a scenario in which the entire planet Earth, all across the board, from the leaves to the algae to the bacteria, all the things that use energy from the sun to create oxygen and, you know, the ATP and the things that all those organisms need to grow, is it possible that that process could stop because of some exterior factor?
Or not even all of it stopping, but enough of it stopping, a high enough percentage that it would render life as we know it non-feasible.
Heard. Okay. That would be, yeah. That would be catastrophic for sure. And it's probably not something that could ever occur in the flick of a switch, right? It wouldn't just stop. But maybe there's a scenario where the lights across the Earth start to slowly go out, you know, starting in one region, and then they just continue to go out like some giant power outage.
Yeah, like the internet outage I just experienced and recovered from. I'm back now, guys. Thank you.
We're glad to have you.
Isn't it funny though? Like the microcosm that you're talking about, Matt. It's like these artificial lights are in a way like an extension of this whole ecosystem, this whole like continuum that we're talking about. Like they wouldn't exist either, and now there's this like whole other layer of inorganic kind of, but yet somehow weirdly organic in origin stuff that kind of mimics the sun.
Well, yeah, because each individual bacterium or algae or, you know, let's just say leaf, each one is a power plant, right? And you do have to imagine that if somehow these power plants just cease to function, or like the mechanisms inside the power plants just broke.
It doesn't have to be 100% for the results, the consequences to be catastrophic. And part of the reason it's easy to ignore these sort of things is the vast discrepancy between what is considered a short amount of time in a human life and a short amount of time for life on Earth, right? So a short amount of time for life on Earth is still thousands and thousands and thousands, if not millions of years. This thing, if plants 100%, like you said, Matt, in a almost as though there were a switch being turned. If plants all of a sudden stopped photosynthesis, the world as we know it would end incredibly quickly. It would not be part of some purposeful conspiracy, but rather an accidental global conspiracy on the part of every single human being. And that's because there are a lot of plants, and to your point, Noel, about the Goldilocks situation. There are currently an estimated somewhere around 375,000 species of plants, but there are more being discovered each and every year. And though I hesitate to use the phrase, they're not all created equally. Some evolved to exist only in extremely specific circumstances. I'm thinking of the largest flowering plant, the corpse flower. It smells like rotting meat.
It's supposed to be a delight. Yeah, but even like cacti, you know? Like, I think I sounded a little wistful earlier when I was talking about you got to have windows or you'll kill your plants. I kill my plants constantly because my house doesn't have very much direct sunlight exposure because of the direction it's facing. But I can keep a cactus alive.
Mm-hmm. Yeah. And look, other plants, to the point about the cactus, other plants are pretty hardy. And they have a large, let's say, margin of error. They have a large tolerance for environmental change. And most plants are autotrophic, which is just a fancy word for saying producing one's own food. And they do this using basic inorganic substances around them: water, atmospheric carbon dioxide, and then, you know, a bevy of mineral nutrients from the soil. This is the real superpower. This is what we were gaga about a few minutes ago. All the, like most of the other living things, the vast majority of other living things on Earth are heterotrophic, meaning we consume organic carbon and we cannot process these raw materials that plants love. We can't do that ourselves. So plants are taking one for the team in a very real way. They are the basis of worldwide food webs. They turn inorganic carbon into sugars, and then everybody else shows up after the cooking is done.
I mean, surely that's where the term plant comes from in manufacturing and in power generation. I mean, plants did it better, and then we had to figure out a way to kind of copy their whole system, to work for our benefit, for like making stuff.
Yeah, whose idea was it to evolve complex systems that don't have thylakoids and chlorophyll?
Okay, nerd.
Like, no, but really, like, why would we not all have that evolutionary trait? Because
it's true.
It's
pretty advantageous, self-sustaining for the most part.
Seriously, we could stand in some water, look up at the sun, and be like, hey, we're good.
Have you heard the hippies that are really into like sunning their buttholes? Like that's the thing.
What?
Yeah, it's a whole. Tell us about it, Ben. It's a whole.
I'm not going to say more about it. Luckily, I'm not an expert.
You sounded like you were. Oh yeah, I know about the sunning of the butthole.
I'm not a practitioner, but
Neither am I. But it
yeah.
is literally just holding your butt to the sun because you need to get that juice, that sun, energy or whatever.
When podcasts don't work out, that's our new startup, solarchakra.com, right?
That is that's
a choice.
I would have thought you would put your root like in a water source, right? And then absorb sunlight.
That's level 2.
That's level where 2. You are planted, my friend. Bloom where you are planted.
It is a good question. I mean, in that scenario, if we want to walk through it, so if what we call animals also evolved to have that power, inevitably, the theory of evolution would argue that something would evolve to predate on that. Not to come before, but to eat it, to use that as a resource. So it's weird, too, because not all plants use photosynthesis. The ones that don't largely evolved parasitic abilities. So they grow on other plants and steal the carbon and water and nutrients from the upstanding plants with an honest plant job, or they feed on decomposing organic material. So while those themselves technically don't practice photosynthesis, they still 100% depend on that process happening somewhere. Again, it's photosynthesis with extra steps. Speaking of extra steps, do we want to talk about how photosynthesis became a thing?
I still can only picture the vague illustration from my textbook in my mind's eye. And I know the basics of it. It's like light in, food out, or basically. I mean, that's like what it amounts to. But then it also creates a byproduct that we need very conveniently and are able to benefit from in terms of oxygen.
Yeah, light and water are the primary things because you got to get that hydrogen and oxygen in there to break down. But which is the craziest thing in the world, that inside plants there's machinery within plants that can oxidize stuff, which is, it usually takes a tremendous amount of energy to do that. As humans have tried to figure out how to oxidize things effectively and what actually breaks that hydrogen from the oxygen, you need a lot of energy. And the plant's just like, no problem.
Right. Which is why they're too busy to travel a lot of times. But okay, let's go to our old colleague, Jesslyn Shields, over at our alma mater, How Stuff Works. She has a great explanation of this. She says, quote, this is the story, how photosynthesis, how we got here, before we get to how it, boils down. Around 1 billion years ago, after the Earth was formed, life showed up, says Jesselyn. Probably first as some anaerobic bacteria, that's the stuff that doesn't need oxygen, slurping up sulfur and hydrogen that came out of hydrothermal vents.
Yum, yum.
Yeah, and then she goes, and now we've got giraffes. But there were 10,000 gigatons of steps on the road between the first bacteria and giraffes. The bacteria had to figure out how to find new hydrothermal vents. This led to them developing a thermal sensing pigment called bacteriochlorophyll, and then some bacteria still use that to detect infrared signals generated by heat. To your point about tiny machines, Matt, that's likewise astonishing. These bacteria, these heat-thirsty boys, were the ancestors of things that could later make chlorophyll. Chlorophyll is also a pigment. It captures shorter, more energetic light wavelengths from the sun, and that's where the power comes in. So props to Jesselyn. What a well-written explanation.
Dude, the idea of capturing photons, and like even as it pertains to like photography, for example, or like, capturing light and harnessing it in some way is so mind-boggling to me, even with our modern technology. Like it's just pretty insane. But like the fact that these organic materials figured out, just like, is it by accident? Was it again just like a set and setting kind of thing? Like because of, again, like the position and just the fact that it was just constantly exposed and nature just needed to find a way to harness that? Like, how do you even put it into words?
Well, we don't know. We know that it's organisms that somehow decided to team up and go inside each other and become the mechanics that function.
The mitochondria, yeah.
I mean, it really is mind-boggling to think that at some point life just decided to do that, or just started to do it, and it worked, so it kept doing it.
And it's a byproduct of that. The oxygen is like an afterthought, and that's what allows humanity to exist.
We're also only seeing the winners. I think that's a very, very important point.
It's just crazy, the layers of it, where again, like the fact that oxygen is just sort of, that's not even the whole point. Like all this other awesome stuff is happening for the plants, and then this oxygen just, also happens to be a thing that allows humans to breathe and walk around.
Yeah. They need the electrons, the hydrogens.
Right.
The oxygen is just get out of here, oxygen.
Get out of here.
What is the fastest way to get rid of this unnecessary ingredient? That's what they're doing. Just like a factory flushing out chemical byproducts into your local water system. I mean, that's kind of what it is. The analogy holds.
If those byproducts were gold and like magic dust, you know what I mean? Like,
well, we would say, again, it's all perspective. If there was a life form that thrived off of the effluvium ejected from factories, then we would say that's gold too. Oxygen didn't care. Right? These things didn't really care about oxygen. It became important later. But these bacteria, after countless of them die and mutate ineffectively and then die again, and this one, somehow at some indeterminable point, a mutation is successful. A bacteria becomes the translator of capturing those photons using sunlight. But they still haven't figured it out. They needed what we would say, I guess we call them batteries. They had to be able to accumulate those protons and hold them on a discrete side of their membrane instead of the other one.
Yeah, and then start passing them down through the process, right? That actually generates all the things, all the different byproducts that become the energy. But then the craziest thing about this whole photosynthesis thing is it's not just one way, like holding the charge and sending it through one way. It then goes back through the other way in the membrane to create other stuff that the plant then uses to grow itself. Mm-hmm. So you're just like, sorry, my mind is so blown.
No, it's insane. Mm-hmm. I'm with you, dude.
Yeah. It's also we have to give honorable mentions to all the other all the other things that came into play, the cyanobacteria, the chloroplast, et cetera, and all of this leads to something pretty dope. Plants. You know them, you should love them, even if you're not a vegetarian. These things take in carbon dioxide and water, as we mentioned, from air and soil, and then they have kind of some feature verses from nutrients, minerals, micronutrients and stuff in the dirt. The water is, as you said, Matt, oxidized. And oxidized just means it loses electrons. This the carbon dioxide, CO2 is reduced, so it gains electrons. This transforms the water into oxygen. Carbon dioxide turns into glucose. The plant is like, I'm amazing at this. And then it releases that oxygen back into the air. Who cares about that? And it stores energy within those glucose molecules.
Not to mention they're delicious, whether or not you're a vegetarian, and they provide us nourishment. I forgot about the whole fact that we can eat the things too.
Figure that part out too. Yeah.
Jeez Louise. And I mean, they are attractive. They make us want to eat them. You know what I mean? And they taste good. And the ones that don't will kill you, or you're some kind of glutton for like a really spicy pepper like Matt.
Yeah, and just if you want to go down this rabbit hole, you really should. Cannot recommend the video series that the Khan Academy has for free. You can watch right now that goes all into the what they call the light reactions, the dark or light independent reactions, all the way to the Calvin cycle. The Calvin cycle is something we're not even going to fully go into today, but like, good. Just re-blow your mind to remind yourself.
I don't remember the Calvin cycle.
Yeah.
It's all that extra stuff of like what
the diagrams within the diagrams with little circle like arrows around it, you know, like with
it's so complex.
Infographic.
It's beautiful. Mm-hmm. It's absolutely beautiful.
I'm sure.
Yeah. Shout out Stomata, Stroma, all the hits.
I remember. Okay. Now you're jogging some memories loose.
Again, the vocabulary is great and all that, but how it works together just. I don't know. It gives you an appreciation. It's like an overview effect that you can get by studying a plant. It's weird.
Well said. Big fans of Khan Academy as well. Can't shout them out enough. And this reminds me of, I listened back to, I can't remember the title, excellent episode we did back in the day about plants and consciousness, because plants do something very similar to speaking with each other. And also, oh man, there's so many great TED Talks too we should mention along with Khan Academy. This is fascinating. I think that's an excellent point, Matt, the idea of the overview effect. You don't have to be an astronaut to encounter it. The world continues on. After all of this brute force evolutionary hacking, the countless back to the drawing board moments, we are here in 2023. We have to remember plants are like any other living thing that humans know of. They have evolved to live in a set of specific ranges and thresholds and circumstances, just like humans can and will die when wet bulb temperature gets past a certain threshold. Plants need a specific temperature to really vibe. By vibe, we mean conduct photosynthesis. To use their superpower, it turns out that past a certain threshold, a temperature can become a kryptonite to the plant's superpower, and they will suddenly be up a very bad river with no way back down.
It's crazy. We've known that those thresholds exist with ambient temperatures in plants since the 1800s.
Since 1864, yeah.
So we're going to take a quick break, and then we'll come back and get into why we're even doing this episode. Like, why are we worried about photosynthesis? There's a real threat.
And we have returned. Also, just because we're going into some of the more disturbing territory here, I want you guys to know we're recording this remotely. The reason I put my handle on here as Photosynth Assist is just because I thought it was a cool pun, and there's not really a way to put it in naturally. So
is that reference to being like this? You simp for photosynthesis?
I'm still not sure.
Okay.
You find the pun first, and then you figure out how.
Wait, that's not how we do science.
That's how plants figured out the oxygen thing.
That's true.
So, all right, here's what happened. There was a paper published in the journal Nature in August of 2023, led by a guy named Christopher Doughty. He is the associate professor in ecoinformatics at Northern Arizona University, and they put in some crazy work. If you are worried about the mass extinction of bees, allow us to introduce you to a nice side dish. Make that existential dread a combo meal.
Your flowers don't work, and neither do your leaves.
Mm-hmm. Professor Doughty says, let's do this. He says, let's get a specific type of instrument, something called EcoStress, a thermal sensor. Let's launch that on the International Space Station, ISS, and we're going to keep it up there for a while. We're going to use 2 years worth of data from 2018 to 2020 to get a big picture of the overall situation. And they didn't stop there. They also looked on the ground. They put
let's talk, before we talk about on the ground, let's talk about just exactly what they're looking at from that big picture.
Sure.
Because when they get photos and information back and temperature readings from all the way up at the ISS, they're looking at 1 pixel equals 70 meters, so like square meters. So that's a huge swath, like an area, right, that they're studying from that overview standpoint. But but you can't get very granular with that. So they needed a way to like get closer to the action, I guess.
Mm-hmm. And if you want to learn more about eco-stress, I cut a lot of this, but it's really interesting. Go to the Jet Propulsion Laboratory over at the California Institute of Technology, Caltech. Just search that in eco-stress, and you can learn in detail some of the stuff Matt is talking about. But you're absolutely right. And so they needed, just as you described, Matt, they needed a closer look. So what we were saying is they did not stop there. They went on the ground. They placed sensors across canopies around the globe, Australia, Brazil, Panama, Puerto Rico. And they were not working off just some sort of inarticulate hunch. Scientists, as we mentioned previously, knew there was something important about temperature in plants as far back as 1864. And what they found then, again, way back then, was that the leaves of some plants could survive temperatures of up to 122 degrees Fahrenheit. For the rest of the world, that's 50 degrees Celsius. And once they got past that point, the leaves would die. Important distinction, not the whole plant. The leaves, the things that are like, it's almost like saying your mouth or your lungs or your digestive system die, right? But your body is still technically alive. And so knowing that, this is how amazing the study is. This professor and his team also pulled a study from 2021, which found that 147 different tree species in tropical biomes, they found that these trees, their photosynthesis petered out at an average temperature of 46.7 degrees Celsius. That would be a little north of 116 degrees Fahrenheit. So good to know, for most of human history, this was not a huge issue. The places that typically reached those temperatures had typically reached those temperatures for a very, very long time. And plants that existed in those areas had adapted to live there. But that might be changing. And here's the kicker. I want to be careful with this and not be too alarmist, but Dowdy's team found that roughly 1 in every 10,000 leaves in their big measurement experience temperature changes right now that are too high for photosynthesis. Those leaves were out of commission. They were dying. It's pretty somber stuff. Science News also points out that this is, to our earlier statement, this is not happening around the world yet. This is happening in discrete hotspots. Oof, accidental pun, terrible. But it's happening in discrete areas similar to the way that monsoons or hurricanes only occur in specific parts of the world.
Yeah, and they're only studying the canopies of tropical rainforest. That's really, really important. And they're only finding that 1 in 10,000 of these leaves are getting affected, or trees are being affected. So it's, at this point from this study, it's sombering, but it's not, and it's not alarm bells going off, right? Because it is just at the very tippy top. When we're talking about canopy, you're talking about the upper levels of plants, because there are all kinds of different plants of different sizes in a tropical rainforest, and tropical rainforests tend to run hot, a lot hotter than other places in other large forests. So we got to keep all that stuff in mind when we're thinking about this, because it doesn't sound scary, 1 in 10,000 leaves. But if we're at a threshold and ambient temperatures are rising across the board, then it could potentially be a much bigger problem pretty soon.
Agreed. Yeah. Science News does it this way. They say, quote, the analysis revealed a mosaic of temperatures in forest canopies. During periods when forests were hot and their soil was dry, temperatures across the canopy reached an average peak of 34 degrees Celsius. Some tracks exceeded 40 degrees Celsius. And going all the way back to the mid 1800s, 50 degrees Celsius is our very worrisome point. About 0.01% of the time, just in the upper canopy, these leaves would hit above the danger threshold. The highway to the danger zone is 46.7 degrees Celsius. The ride out danger zone proper, 50 degrees Celsius. And that means that on a regular basis, Earth is beginning to hit that limit past which photosynthesis simply will not occur.
But it's not like this would happen overnight with like it's a gradual process. And it's like you described earlier, Matt, the idea of like a power grid, like visually going down, kind of cascading, but maybe on a much longer timeline. Or what kind of timeline are we talking?
Well, yeah, we'll talk timeline, but the big thing to note is this is the canopy of a tropical rainforest region. So if ambient temperatures in that specific band around the Earth exceed those levels on a regular basis, you're talking about killing or potentially the leaves in that upper level dying. Now, if those ambient temperatures reach all the way down to the ground level, right, in the dense forest, then you're talking about potentially killing off leaves basically vertically as you're moving down towards the ground.
And there's a snowball effect because those leaves in every level of the canopy above, right, those leaves also provide cover and cooling for the levels beneath them. So there is the possibility for an exacerbation of this. And to your question, Noel, regarding how this all breaks down, I found a really fun thread on one of my most enjoyable subreddits. They did the math. It's the unnecessarily, well, I would say it's very thorough math about all sorts of strange questions. And one of the estimates there, they said, okay, let's assume photosynthesis, even though it won't happen, let's assume it all goes dead at once. And we just have a finite amount of oxygen from that point on. How long would it take humans alone to suffocate themselves in the escape room of Earth? The answer, 704,000 years.
Oh, well, then we're fine.
Yeah. Well, because algae, like ocean algae is the primary oxygen source, right? I mean,
around 70%. Yeah.
So we would
it's
be able
good to know. Not doesn't give us a pass, but it is good to know that like this isn't an immediate apocalyptic event, like breathing up all the air like in a mini sub or something.
I do know I've got to give a shout out where it's due, credit where it's due. The only reason I know the algae stuff is because of the film Waterworld. Watching that, I thought, well, all the plants are gone except for this one island. How could they breathe? And that's when a friend helpfully pointed out, well, Ben, algae create most of the oxygen.
That's also where I learned about desalination, or at least in terms of pee. And remember that scene? So I think it's the one everyone remembers, where he's on the raft and he pees into a thing and then he drinks it. I guess that is a still suit, basically. It's a portable still suit. But
that boat was so cool. What is the name for those? Is it a catamaran?
I think it is.
The trefoil.
I just remember Dana Carvey did a joke about it, like as Bush or something. They say, you can't pee into a Mr. Coffee and expect taster's choice.
Classic. That guy had such a good stand-up career in the cards. But so, okay, there are things that make this number, there are problems with this number. I mean, you can walk through the math, you can see it. The people on Reddit posting this did a great job. It doesn't factor in a lot of other things. It doesn't factor in, for example, all of the other non-human animals that are big fans of breathing oxygen on a, dare I say, regular basis. It doesn't factor in comorbid stuff, increases in population, the fact that mass starvation will occur before the oxygen, quote unquote, runs out, climate chaos, which again, I think is a far more accurate term than the sort of milquetoast climate change we've been using. So it seems like, again, without being experts, that while 704,000 years is a long, long time, things hit the fan way, way before that point. But the good news, like you said, Noel, this is not going to immediately lead to disaster. 0.01% is not a big percentage.
Selfishly, I was like, my immediate calculation was not within my lifetime or the lifetime of my kid or loved ones. So I'm good, but that's really a selfish way to think.
Well, that may not be true, Noel.
Really? Okay, yeah. Go on.
Well, and it all depends on how runaway, the greenhouse effect becomes, right? And if it does get really bad, if rising ambient temperatures expand out of that tropical zone and keep moving towards the poles, and it gets worse and worse and worse, then what is the year, Ben? We both talked about it off air, like 2100.
2100 would be the time that greenhouse gas emissions push the world to that amount of warming. That amount of warming right now, experts estimate these plants can survive about 4 degrees Celsius of warming above the current levels before trees lose all their leaves, the plant version of going bald, and then die. It wouldn't hit the entire earth at once. Plant die-offs follow the pattern of, I gotta stop saying hotspots, follow the pattern of the warming here. Right. So, for instance, in the poles of the planet, this warming, like the transformation of the tundra and the thawing of permafrost, that's going to be a very different situation than what will occur in the equator and in the tropical areas of the Earth.
Guys, is it still even remotely controversial, like climate change, climate chaos? Are there still people that find that to be maybe? No, and we're not. The jury's still out.
Yes, there are people who feel that way, but I think it's safe to say that the science so far is unanimous. Now that the corporations who were paying for opposing voices, now that they are exposed, it's increasingly less controversial. I don't think it's controversial at all.
I think it feels maybe more like a political talking point, on one side of an argument to I don't know if even the people that say it believe it. You know what I mean?
I think it was Vladimir Putin just recently had, I think it was yesterday, we're recording November 9th. This was on November 8th. He started asking these very strange questions about ice in Antarctica. And he was like, how much ice can you store in Antarctica? Repeatedly. And
is that like a riddle?
I don't know. Is it a code?
Very interesting.
Western analysts are speculating that is an attempt to cast further aspersion upon the idea of climate chaos. But yeah, to your point, political, I think.
Yeah, it doesn't help that there are all kinds of strange sounding schemes like carbon offset programs where you can just somehow pay your way out of the pollution your corporation generates.
It's like paying indulgences to the Catholic Church so that you could sin.
It's like The Economist loves it. The Economist and neoliberals love that one.
Well, yeah, but it does not help the skepticism, I think, that exists out there. Agreed. for this science behind the subject, because it does feel like it's being taken advantage of by people who want to make money and want to be able to spend more tax dollars on things that are not probably helpful. Anyway.
I mean, there's also the fact that, look, when you hear these numbers and it's a bit of a roller coaster. Plants are dying because it's getting too hot. True. That does seem to be the precedent. That does seem to be the pattern that will continue unless variables change. But there's still a bevy of other factors at play. There already is a growing impact on historical agricultural resources, the so-called breadbaskets of civilization. The interior of the U.S., parts of Europe, Asia, India, parts of Africa, and, the biodiversity of South America and Southeast Asia also under intense threat. And they would be dealing with this growing plant die-off in conjunction with unpredictable weather, droughts, flooding at the wrong time, and, of course, the ever-present growing threat of political instability. The truth is, we don't know everything about the fallout here. We also don't know everything about the adaptive abilities of every tree species. Humanity still doesn't know how many plant species exist. There are many unknowns here, and we also don't know how the deaths of individual leaves impact the mortality of a given species of tree. And so that's why there are some people saying, hold on, we might be overestimating vulnerability. One guy, ecologist Christopher Still, so he's not just some guy, he is an ecologist. He said, maybe we're making this assumption that when leaves hit this critical temperature, they die. That's a cold comfort, though, I would argue. It's a bit of a fig leaf in the face of what may well become an existential threat. I mean,
you're saying we're just barely covering it up just enough to where it can still walk around and we wouldn't be embarrassed by what's under the fig leaf? Okay, got it.
Just enough to tell later generations, well, we put a good hustle in. It was a big swing. And my question, though, is this a possible tipping point? Like, what happens, not when 100% of plants stop photosynthesis, that seems very, very far away and alarmist, but what happens when a certain percentage of them stop? How do you guys think this shakes out?
It's going to get real weird because, there are massive ice sheets on Antarctica that are now beyond the point of being able to maintain, right? So there's some serious melting occurring there. There's going to be a lot more water within the whole system that we run in here, both in the oceans and in the skies. So plants are going to have no shortage of the hydration they need to continue photosynthesis. They're going to have no shortage of sun because it's just hanging out there blasting the earth. If we could,
I love that image, Matt. The sun just hanging out, blasting the earth.
Well, it blasts everything.
Oh, it blasts
right?
everything. But isn't? Remember we were talking in the beginning about how and what a coincidence that it's this exact right distance as the ozone layer continues to be depleted and stuff. I mean, is that going to become? I know that the warming is one part of it, but just like the heat, I wonder.
Not long ago, the ozone holes, some of the major ones were beginning to fill in, which was actually good news.
Yeah, it's on due to the success of the Montreal Protocol. The ozone layer is actually getting better. Yeah.
Thing. Okay, maybe I'm not aware of that. That's
going to take about 4 decades.
Got it.
Yeah, the big thing now is just heat trapping that still occurs. Heat trapping within the system. But I don't know. The plants,
they're resilient buggers. That's for sure.
That's the thing. We see it on a human lifespan because that's all we know. And we measure time in life and death of humanity, right?
Right.
Generations.
Timeline discrepancy we were talking about earlier. Yeah.
Yeah. Sorry. I don't mean to retread things. It's just, I think it is a matter of perspective.
Oh, yeah. No, it really makes you think, how that we're just a blip. I mean, no, just the idea of the evolution and the connection and the fact that plants are really not about individuals. They're about the whole system, and even if they were to go away, you have to imagine that byproduct that we've relied on, that would be the issue for us. They'll probably evolve into something else over time on another planet, on another star, whatever. I mean,
I forgot to tell you guys, I read this. I got really into research with fungus in space. I didn't know this, but fungus is a huge problem for astronauts. Were you guys aware of this?
Because they're always tripping balls when they're in their spacesuits and freaks them out.
Well, it's literally their balls. It's ball fungus.
Oh, no
it
joke.
It grows. Yeah, it coats mechanisms, coats windows, everything. It's actually a really good argument for panspermia, which still needs a better name as a theory. But
sperm, another thing that astronauts are plagued by.
Yes.
Floating around. Wait a minute, what?
Just float around in this.
Just globules, just like
in space. No one can hear you. You know what? Never mind.
No one can hear you scream.
You got
too good. I'm sorry, I didn't.
But
want to
this disaster though, and I do hope this was worth an episode. I hope not making a mountain out of a molehill. If so, I apologize. But we gotta remember this disaster occurs concurrently. It's in step with other things that are on the way. Widespread drought, climate migration on massive levels, rising oceans, the long-term effects of microplastics, the list goes on and on and on. And fortunately, so does the science.
Well, and while this is an existential threat episode, I found it very educational and enlightening as well. You know what I mean? It was really fun hearkening back to some of those earliest memories of like learning about what science is and how magical these systems are, you know, and how utterly mind-boggling their existence is, you know, and again, I hope we don't see any of these ramifications in our lifetime. Do you guys think there's mitigation for this? Like, is it too late? Have we swung too far? Not enough people care?
Well, it's difficult, I think, sometimes to articulate in an impactful way consequences that do not seem immediately apparent, right? Going to that idea of perspective and time scale. Maybe we mentioned this, I think, on a previous recording, but maybe one of the best ways to think about it is, okay, the car accident, like climate chaos is like a car accident. And in this comparison, the accident is already happening. The car has left the road. We can see the tree ahead. The question is, what do we do in those figurative few seconds before the car hits the tree?
Jump out of the car.
Space!
We find a new car, or we walk. Never set foot in a car again.
So maybe it's a matter of, and that it's not the best comparison, but maybe it's a matter of seatbelts, airbags, swerving, to what degree that can occur. But it takes a lot of collective global action in a way that is relatively unprecedented.
It was nice to hear that the ozone holes are better, are doing better. Like that was news to me. Like, I'm not joking. I was like, wait, cool. Okay, that's some positive silver lining.
Yeah. It's so weird because we have experienced over our lifetimes a lot of alarmism over this stuff, right? Probably rightly so. It's balancing the fear we need to have in order to take action, right? With the knowledge that fear it has to be tempered. Because if we're just freaking out about it because it feels so dire, we're not going to get anything done. But if you don't have enough fear, you're not going to get anything done either. So I don't know.
And I think we always strive to be as not alarmist as humanly possible, to just lay out the facts, approach it with a little bit of lightheartedness, because what else can you do? And hopefully we're not trying to freak anybody out or make anyone feel despaired, but this is something to be aware of, but also don't let it keep you up at night, I guess, if you can help it. Or do. I don't know.
We have to, maybe the best way to put a button on this is to say, look, you can put political ideology, corporate perspectives, cultural differences, all that jazz, all that space fungus to one side, because none of it alters the simple fact. The clock is ticking. And the question is, what does humanity do in response? And hey, folks, thanks as always for tuning in. If you can fix this, if you can share with us the immediate solution, we would love to hear it. We will forward it everywhere. All you have to do, or if you have, we want to hear your take on this from your neck of the global woods, ideas for future episodes, limericks, cool puns. Surely we can do better than photosynthesis. So let us know what's on your mind. We try to be easy to find in a variety of ways.
Oh, you're not even the simp. You're the assistant of the simp. It's a very fraught concept, Ben. I love it. But you can indeed write to us about that, make up new words, send it to us. You can find us on social media. We are Conspiracy Stuff on YouTube, Facebook, and X, nay, Twitter. Conspiracy Stuff Show on Instagram and TikTok.
Hey, do you like to talk on your phone? Well, talk to us. Our number is 1-833-STDWYTK. It's a voicemail system, guys, that happens to be empty right now. We need new voicemails. Yeah. So, when you call, you got 3 minutes. Give yourself a cool nickname and let us know if we can use your name and message on one of our listener mail episodes. If you've got more to say than can fit in that voicemail, why not instead send us a good old-fashioned email?
We are the folks who read every single email we get. Send us those links. Send us those photos. We can't wait to hear from you. Conspiracy@iHeartRadio.com.
Stuff They Don't Want You to Know is a production of iHeartRadio. For more podcasts from iHeartRadio, visit the iHeartRadio app, Apple Podcasts, or wherever you listen to your favorite shows.